All right, we are on 3.5, cruising right along in this unit. We are doing linear relationships, and yet again, we will be using Desmos to help us through our lesson. So Ava has multiple coupon codes to use for discounts at an online clothing store. She's debating between using a $15 off coupon or a 20% off coupon, but isn't sure which will give her the greatest discount. For what range of prices is each coupon best? So we're going to use Desmos. First, we're actually going to create some equations, use Desmos, and graph each. So I have two different options. So I'm going to create two different equations to plug into Desmos. So the first one, super easy, a $15 off coupon. So we just take our price of our item and we subtract $15. There's our equation or expression that we'd plug into Desmos. And our second option for a coupon is 20% off. So what does that look like as an equation? Well, it's going to be the price of my item times 0.8. And how did I get 0.8? Where does that come from? Because I thought we were using 20%. Well, this 0.8 comes from 1 minus 20%. That gives me my 0.8. I'm paying for 80% of the item with that 20% off coupon. Hopefully that made sense to you. If not, let me know. Okay, so now I'm going to open up Desmos and I'm going to graph both of these equations. So we have x minus 15, that shows up in red. Zoom out a little bit. And then my second one I have as y, I don't know if I can use y, but let's see if it works, times 0.8. Nope, I have to use x. Okay, x. Okay, so that one shows up in blue on our graph. And now think back to the Math 1 days, maybe other math classes too, I don't know. Okay, we have a system of linear equations. And notice they intersect at 75, 60. So what does that mean? Okay, well, my x value is what I am spending on a certain item before any coupon code is added. X minus 15. So the original price of the item minus $15. So the price of my item is $75 minus the 15. So that equals y. So my y value is what I pay in the end. So my $75 item is now $60. And for the second blue equation, x times 0.8. I'm paying 80% of the original price. Well, the original price was $70 times it by 0.8, meaning I'm paying $60. So this intersection point is when both deals are the same. So when she spends $75, both deals are the same. She's paying $60 for each item. That's my break-even point. I think it's talked about later on in this section here. But break-even point where they intersect. Now, which deal is better when? Okay, well, if I'm spending less than $75, so I'm going to look for everything to the left of that intersection point, which one is going to be cheaper? Okay, well, the red line is below the blue line, so that's telling me it's going to be cheaper. So if the item is less than $75, my red line, which is my $15 off coupon, that one's going to be better. So less than $75, $15 coupon is better. And if it's greater than $75, so I'm looking to the right of that intersection point, the blue line is going to be the better deal. So more than $75, the 20% off coupon will be better. If you don't believe me, you could always plug in numbers to see which one is cheaper. So pretend that you were buying a $20 item. Plug in 20 for each of these. See which one's cheaper. Then go ahead and plug in $100 and see which one is cheaper. So if you didn't like my visual representation, you could always do it algebraically. Okay, moving on to the next one. We're doing number 2 next. Okay. Oops. don't think Desmos is going away today. Okay. There's a huge, long example here on different ways to solve. You can solve numerically, algebraic, or graphically. Okay, so same thing, similar to this problem here. We have our two equations. Are you going to spend $3.65 for a gallon of gas with a $5.50 car wash, or are you going to pay just the $3.85 per gallon? Okay, so one you're paying more, the other one you're paying less, but you still have to pay $5.50. So there's three different methods you could use: numeric, algebraically, and graphically. They walk you through all of those. If you are doing anything that uses like a calculator option, I would always use Desmos, create a table for those, kind of like I did here. All right, question number 2. Deanna and her sister Emily own a small home-based business creating gift boxes with special wrapping detail for each item in the box. Emily can pack a box in 6 minutes, and Deanna works faster. She at 4 minutes per box. But she has to join their packaging session 20 minutes after Emily. Okay, so let's break that down. What does that mean? Okay, so Emily's slower. Deanna's faster. But Deanna is going to start 20 minutes after Emily starts. Okay, so use the graph shown on the following page to determine how much time will Emily have to work with Deanna, or how much time will Emily have worked when Deanna has completed as many boxes as Emily has? How many boxes will each have completed at that point? Okay, so essentially we're looking for the break-even point. When will their boxes match their times for both of them? And it's going to be this intersection point. So 10 boxes in 60 minutes. Okay, we found that straight from the graph, the intersection point. Perfect. Now, what if we didn't have a graph? What would we do? So I think we're taking like a step backwards here. So pretend the graph doesn't exist. Write a function to describe each line. Okay, so Emily can pack a box in 6 minutes. So her time will equal 6 minutes per boxes, n being the number of boxes that she's packing. And then for Deanna, she can pack 4 boxes per minute, but we have to tack on 20 additional minutes because she started 20 minutes after Emily. So we have to give her 20 extra minutes. And then I'll label my variables so that all of you know what I'm talking about, because maybe you used different variables than me. So make sure that you always label your variables. So N is going to be the number of boxes, and T is going to be the time in minutes that she, either one of them, has worked. Write an equation to find when Deanna and Emily have packed the same number of boxes. So when will Deanna equal Emily? So I'm going to set both of those equations equal to each other because I want to know when they will be the same or equal. So that was probably the hardest part of this problem, was like figuring out, oh, I need to set them equal to each other. Okay, from there, I think you should be able to know what to do, but we're just going to solve for n. So I'll subtract 4n from both sides. I get 2n equals 20, divide by 2. So n equals 10 boxes. The number of boxes is 10. And then I'll plug in this 10, I'll plug it back into really either one of those equations. I'm going to do it for Emily because her equation's smaller. So the time is going to be 6 boxes times 10 minutes for a total of 60 minutes. So in the context of the problem, what are we saying? After 1 hour, they'll both have packed 10 boxes. So it doesn't matter if I solved that graphically or algebraically, I got the same answer in the end. Moving on to number 3. Nate's wife recently had triplets. knowing that diapers are going to be part of their lives for a few years, he looks into options for buying them inexpensively. A jumbo box of a brand he likes costs $30 in a town with a 6% sales tax. At another store in a town nearby, he can buy that same jumbo pack for $26, but the sales tax is going to be 7.5%, so a little bit higher in sales tax. If he buys online, Amazon, he can get a jumbo box for $25 with no sales tax, but he does have to pay $8.50 for shipping. So Nate uses Excel to look at the numbers. Which option is best for how many boxes of diapers? Okay, so looking at, if he just needs one box of diapers, it looks like the second store, cheaper box, more sales tax. That's going to be the best deal. For 2 boxes of diapers, again, the second store is the better deal. It has the least cost. I think I said that wrong, but whatever. Then for 3 through 22 boxes, really the online store is going to be the cheapest option. At no point in time, unfortunately, is the first store going to be the better deal. I mean, look at when we get to 22 boxes of diapers, there's over $100 difference between the first store and the online store. So definitely not the best option there. Okay, so I do need to write that out in sentence form. So I would say if he only needs 1 or 2 boxes, it's cheaper just to go to that second store. But if he's buying 3 or more boxes at one time, the online store is cheaper. Hopefully he doesn't need to buy, or he doesn't buy 22 boxes of diapers at one time, because that's $558 at one time for diapers. Okay, and I think that's all I said we were going to do today. Oh, no, I lied. I said we were going to do number 4. Actually, I said we weren't going to do number 3. That's a mistake up here. Let me erase that. Okay, we're not doing number 4. We're doing number 3. Okay, perfect. We're done for the day. Do the homework.